Good morning. So in the last class, we have discussed about the different types of rate of return methods. So internal rate of return and external rate of return and minimum acceptable rate of return. So in this, we have internal rate of return, that is at which all the cost of business is equal to the all its revenues. Means and cost, the present worth of the cost and is equal to the present worth of the revenue. So net cash flows or net worth is going to be zero in the case of at particular I is equal to IRR. So that we are going to discuss today by taking one problem. So here we have a cash flows. We have a cash flows of say a company. Okay, having the new product line. Of course, the life of the project. Life of the project is given. Life of the project is given. Is say 10 years, and there is no salvage value and no salvage value. And of course, the initial cost of the project is given. Initial cost of the project, which is equal to rupees 20 lakhs. Rupees 20 lakhs. And the annual net profit. So this is the profit. Annual net profit is given as rupees 3 lakhs, say 50,000. So find the rate of return. Find the rate of return for the business. Find the rate of return for the business. So here, here the cost is given and the profit also, it means expenditure and as well as revenue, both are given. So in this case, we need to find out the rate of return. So we know that what is the rate of return is. So rate of return is nothing but at which the net present worth is going to be zero. It is the rate of return is nothing but at which the present worth is going to be zero. That is called as rate of return, right? So for that, first what is given? So we need to know that the given data, life of the project is given. Life of the project, which is given as 10 years, means n is 10 years. Then initial cost or first cost. Initial cost or first cost is given, that is rupees 20 lakhs. And also he has given the annual profit. Annual profit or revenue, we can say it is rupees 3 lakhs 50,000. 3 lakhs 50,000. For this case, say if I draw the cash flow diagram for the given data, so there is initial cost at time is equal to 0, which is equal to say rupees 20 lakhs. Rupees 20 lakhs. Then at the end of first year, sorry, there is a revenue. At the end of first year, there is a revenue. So we are going to draw upward. That is a profit. So rupees 3 lakhs 50,000. At the end of second year, rupees 3 lakhs 50,000. Likewise, at the end of 10th year, we have, there is no salvage value, so I can write only up to this. So we need to find out the rate of return for this kind of business. Means first we need to write the present worth equation for this. Present worth equation for this cash flow diagram. So we have studied that present worth equation. Present worth equation for this cash flow diagram we need to develop. So how to write the present worth equation, which you have studied in the first, beginning of this module. So present worth can be written as, so what is this here, the revenue dominated cash flow diagram. So cost will be written as negative minus P plus these cash flows shows the annuity. This cash flow shows the annuity. So I'll write down annuity, and what we are finding, present worth you are finding for the given annuity and I comma n. So this is the equation, present worth equation, which is written for this cash flow diagram. So by using this, if I substitute that minus 20 lakhs plus A is rupees 3 lakhs of 50,000, then P by A comma I is unknown and n is equal to say 10 years. So here this is the present worth equation which you have got. Say for example, if I substitute the, say for the value of I, for the value of means, if you take this is a graph, this is a on y-axis, if you have taken the present worth and internal rate of return is on the x-axis, so there will be a line, means for a value of I 0 1 2, if you substitute, then it will be keeps reducing the value of present worth, and at particular point of time, at a particular point of time, say at this particular point of time, for value of I, for value of say I, that is going to be present worth is going to be 0 in this case. Similarly, here we are going to find out for the different values of I, for the different values of, say for example, I take the I is 10%, because if I take the 10% as the rate of interest in this case, then what will be the equation? Say for example, present worth for 10%, present worth for 10%, I'll be getting minus 20 lakhs plus 3,50,000, and here the factor will become P by A, comma, because I have taken the 10%. So we'll be finding at which point, say for example, at 10%, what is the value of present worth in this case? So here minus 20 lakhs and 3,50,000, then I'm going to get the factor. I'm going to get the factor for P by A, comma I, comma, I mean 10, comma 10. So 10, comma 10. If I look into that table, I'll be getting 6.1446. So by using this, I'll be getting the value by simplification. I'll be getting present worth is going to be rupees 1,50,610. So here still the present worth is positive. The present worth is positive, means I need to go for one more substitution of I is equal to, say for example, I'll be taking 12%. I'll be taking 12%. So present worth at 12% is equal to, once again, I'll be using the same equation for the different values of I. Then 3,50,000, then P by A, comma, say here 12, comma 10, 12, comma 10. So now if I substitute the value of this minus 20 lakhs plus 3,50,000, so P by A and 12, comma 10 means 12%, 12%, and for 10 years, the factor is going to be 5 point, from the table 5.6502. So if I simplify this equation, I'll be getting rupees minus 22,430, means there is a change in the value of at 10% and 12%. Say for example 12%. So at 10% you'll be showing the present worth is positive. It is say 1,50,000. At 12% it is showing the negative at this particular point. So it means that there is I will be there in between 10 and 12, in between 10 and 12. So by using this interpolation, we'll be getting the I value. So for that, I write the equation I is equal to, so what is the 10%, which is in the beginning, because we have the 10%, we have the 1,50,610. At 12%, we have the 22,430. So in between we have the some x%, which is going to be 0. The present worth is going to be 0. That we are going to find out. So that at 10% plus, because the interpolation we use here, at 10%, what is the value of the present worth? At 10%, present worth at 10% minus present worth at 0, x, at x, divided by present worth at 10 minus present worth at 12% into the difference in the percentage, that is 12 minus 10, the difference in the 12%. So by using this way, I can find out the I value. So here 10% plus, then PW10 means present worth at 10% is how much? 1,50,610 minus present worth at x. X is you need to find out, that is say at 0. I mean, the present worth at x is equal to 0, because we need to find out the rate of return at present worth x, which is going to be 0, So then 1,50,610 minus present worth at 12% is minus 22,430 into difference is 2. So by simplifying this equation, I'll be getting 11.74%. I means this is the internal rate of return at which this, the net present worth is going to be 0. So he's going to find out what is the rate of return for this, for his company, for his alternative. Say for his alternative. So what is the value which I got is at which the point the net worth is 0. Means the net cash flows are 0. Means present worth of revenues minus present worth of cost, which is equal to 0 at I is equal to IRR. So based on this, we are going to find out the internal rate of return for the any alternative. Likewise, say for example, if I have a different alternatives, so how to find out for the different alternatives also, we need to check. See, for example, I have taken one more. So in this, I have a firm. A firm has 3 alternatives. Okay, there are 3 alternatives which needs to be chosen. So if I say say alternative 1, say alternative 2, then say alternative 3, and which has the investment, means investment in the sense of it is initial cost, and also we have the annual net income. So we have, this is the cost and this is the income for the different alternatives. So what we have is, for the alternative 1, we have the, say, rupees 1,50,000, and the net income is rupees 45,570. For the alternative 2, we have the rupees 2,10,000, and for the revenue is going to be 58,260 rupees, say, and 2,55,000 is the investment for this, and then income is rupees 69,000, and is asking for, there is a minimum attractive rate of return for the firm is there. Okay, so there is a minimum attractive rate of return is also there. We need to compare this minimum rate of attractive return. Based on that, when I'm looking at this, which is best alternative, if I want to find out by using the rate of return method. So this is not used for calculation. This is for comparison purpose. We have to take this MER is equal to 12%. Okay. So first we'll go by alternative 1. So what is alternative 1 says here? Alternative 1. So based on the alternative 1, which you have the given data is initial cost. I can say initial cost which you have taken, that is P, which is rupees 1,50,000. Okay, and then we have the annual net revenue, which is equal to A, because it is annuity, because every year, at the end of every year, I'll be getting, this is the amount of as a revenue, as the 45,570 as the revenue for the particular alternative by investing 1,50,000. So if I draw a cash flow diagram for this, at time 0, we have the cost at say 1,50,000, and of course service life they have given us 5 years. service life is given as 5 years. We'll take the 5 years. So time 0, we have the 1,50,000, and time 1 at the end of first year, at the end of second year, and then at the end of third year, at the end of fourth year, at the end of fifth year, we have the, of course, there is no salvage value here also, in this case also, rupees 45,570 and rupees 45,570. Likewise, up to this rupees 45,570 for each we need. So here we need to find out the present worth equation for the given cash flow diagram. For the given cash flow diagram, we need to find out the present worth equation. So what is the present worth equation in this case? So present worth equation for the above cash flow diagram is, because it is a revenue dominated cash flow diagram, so I'll take the cost as negative minus P plus, because this cash flows all shows the annuity, so A into P, we are going to find out the present worth for the given A and I comma N. So here I is not given. Don't confuse with this MERR. MERR is the minimum attractive rate of return. Means if I get 12%, then alternative 1 will be minimum 12% is expecting. Say for example, alternative 1 is less than 12%, then alternative 1 cannot be chosen because it is not meeting the minimum requirement of the condition. That is, minimum requirement is 12%. Minimum requirement is 12%. So if it should not fall the minimum value, it should be above the 12% only, above the 12% only. So in this case, if I substitute the present worth, in this case, I'll be getting minus 1,50,000 plus annuity is 45,570, and this P by A, I don't know, N, I know it is 5 years. Life of the alternatives I was given as 5 years. Right. So now for the different values of I, I have to get this as a 0, So if I use this present worth equation for the different I values, see here if I use the I value as, say for example 15% or 15%, say I is equal to 15% I have taken. So in this case, PW 15%, it is going to be minus 1,50,000 plus 45,570, and here the factor is P by A comma 15 comma 5. So now for the different values of I am checking the present worth of this particular equation. So if I substitute this and then if I find out the factor from the compound interest table, I'll be getting for the value of P by A comma 15 comma 5, which is 3.3522. This is from the table 3.3522. So once you find out this 3.3522 and then simplify this equation, so I'll be getting rupees 2,759.75. Okay, so this is the present worth value of the at 15%. Similarly, if I go for present worth value for 18%, so for I is equal to say 18%, because it is very nearer, 2,750 very nearer. For this I is equal to 18%, present worth for 18% is equal to, I can write minus 1,50,000 from the present worth equation plus 45,570 into P by A comma 18 comma 5. So similarly, by simplifying this and substituting the value of value of the factor, that is P by A comma 18 comma 5 from the table, which will give, it is 3.1272. So where I'm going to get the present worth in this case is going to be minus 7,493 3.50. You can use even 16 also, or you can use the 17. So you can use the 17 also here. Okay, so now what I do is, because there is a change in from positive present worth to negative present worth, so in between this 15 and 18, in between this 15 means present worth of 15%, we have the 2759.75. At X rate of percent it will be 0, and we got at 18% we got the minus 7493.5. So in between means between 15 and 18 there is a chance to get the present worth is 0. To get the present worth is 0. So now what we do is, we are going to calculate the X at which this present worth is going to by interpolation method, because it will be always greater than the 15%. So IRR or I is equal to, or IRR is equal to, I can take as IRR is equal to, that is equal to I 15 plus present worth at 15% minus present worth at X divided by present worth at 15% minus present worth at 18% into the difference, of this 18 minus 15. Okay, so here by using this equation, then I'm going to find out the actual IRR. So IRR is equal to 15 plus, substituting the values, that is 2759.75 minus at X we are taking as 0 divided by 15%, it is 2759.75 minus at 18% we have the minus 7493.5 into the difference is 3, right? So by finding this, by simplification I'll be getting 15.81 percentage. 15.81%. This is, so it is greater than, this is greater than the MARR. What is the greater than the MARR? Because MARR is 12%. So yes, this can be acceptable, but after after checking the alternative 2 and alternative 3, then we can choose the best one. Now we'll go to the next alternative 2 in the same fashion. So what is the initial cost for the alternative 2? It is given as 2 lakh. Now we'll take the alternative 2. So in this case, given data is initial cost is 2,10,000 rupees, 2,10,000. And similar procedure I'm going to follow for what I have done in the case of alternative 1. So annual net revenue is given as rupees 58,260. Then by using this, what is the cash flow diagram for this is going to be, say at time 0 we have the initial cost of rupees 2,10,000, and at the end of first year we have the annual revenue of 58,260. At the end of second year I have rupees 58,260, and so on at the end of third year, and at the end of fourth year having the same amount at the end of fifth year also. So this is the annuity which is given. Now based on the cash flow diagram, we are going to write the equation. That is for the present worth. What is the present worth equation? So present worth of this particular cash flow diagram is given as, because it is revenue dominated, so minus P plus, and annuity. These cash flows represent the annuity. Into P by A, comma I, comma N. So which is equal to, I can write the substitution, minus 2,10,000 plus annuity is given as 58,260 into P by A. I don't know. We need to find out. N is for 5 years. So now for the different values of I values, we are going to find out the present worth, which changes the present worth from positive to negative. That we need to find out. Say for example, at I'll be taking at I is equal to say 12%. I'll take I is equal to 12%. So at this I is equal to 12%, what is the present worth at this point? It is going to be minus 2,10,000 plus 58,260. So which is P by A, comma I is 12, comma 5, 12%, comma 5. So by using this equation, I'll be getting minus 2,10,000, and the factor from the table 58,260, into which is for 12% and 5 years it is going to be 3.6048. So 6048. So then what is the value? If I simplify this, it is going to be around 15.65. It is 15.65. So this is the present worth at 12%. So which is very nearer to the 0. Then if I take the 13% here, I is equal to 13%. So at this particular point of time, that is P is equal to 13% minus 2,10,000. 2,10,000. Yes. Then 58,260. The factor is now P by A, comma 13, comma 5. So at this particular value of P by A, which is 13, comma 5, I'll be getting the factor from the interest table is minus 2,10,000 plus 58,260 into P by A, comma 13, comma 5, which has 3.5172. So by simplifying this, I'll be getting rupees minus 87.93. 87.93. So this is the present worth which has the negative values, right? So there is in between the 12 and 13, there is a present worth is going to be 0. So by looking at this, we'll be getting say at 12%, the present worth is going to be 15.65, and at X% it will be 0. And at 13% it will be having minus 5,087.93. So we need to find out the value of this at what percentage of X the present worth will become 0. So we use the equation that is IRR. That is IRR is equal to, that is I is equal to say 12%, that is plus 12 plus present worth at 12% minus present worth at X divided by present worth at 12% minus present worth at 13% into the difference, that is 13 minus 12. So IRR is equal to 12 plus, substitute all these values, 15.65 minus 0 divided by 15.65 minus 5,087.93. So into 1 means that is 1, right? So what value I'm going to get is going to be 12 point. This will become very minute 0. We are going to get the 0 and nearer to the 0 value, so some 0.000, say for example 0.001, okay, percentage, right? So now this IRR is going to be made very nearer to the approximately equal to the MARR. Of course, this is also can be acceptable. Now coming to the third alternative, so which is given as so for alternative 3, we are going to calculate the same calculations, that is alternative 3. So what is the equation? I mean, alternative 3 initial cost. Alternative 3 is the given data is initial cost, which is equal to rupees 2,55,000, and the annual net revenue. The annual net revenue is going to be rupees 69,000. So for the given data, I have drawn the cash flow diagram. See, for the given data, I have drawn the cash flow diagram, which is at time 0 we have 2,55,000. At the end of first year we have the revenue of rupees 69,000. At the end of second year we have the rupees 69,000. Likewise, at the end of third year, and at the end of fourth year, at the end of fifth year, we have the rupees 69,000 as the revenue. Okay. So based on this cash flow diagram, I'll write the equation. See, I'm following the same procedure for all the alternatives similarly, right? Writing the present worth equation, which is equal to, because it is revenue dominated, so minus P plus A into P by A comma I comma N. So now what is the P value here in this case? Minus rupees 2,55,000 plus A is given as 58,260. So then I can take the P by A comma I comma N is given as 5 years for all the alternatives. Then now we calculate for the different values of I, means at which the present worth is going to be changes from positive to the negative, So here I'll substitute the 11%. Say at 11%, present worth at 11% is equal to minus 2,55,000 plus 58,000. Sorry, it's not 58,260. It is 69,000. It is 69,000. So 69,000 into the factor which I have taken P by A comma 11 comma 5. So it means that minus 2,55,000 plus 69,000 into the factor value. What is the factor value for the 11% is? From the compound interest table, I'm going to get 3.6959. So by using this present worth at 11%, I'm going to get the positive value, of course, rupees 17.1. So it is very nearer to the 0. So then we can take the next as a 12%. We can take the next as the 12%. I is equal to 12%. So when I take the I is equal to 12%, PW at 12% is equal to minus 2,55,000 plus 69,000, then P by A 12 comma 5, which is equal to minus 2,55,000 plus 69,000 into P by A, it is going to be 3.6048. So by substituting this, I'm going to get present worth at 12% is we are going to get rupees minus 6,268.8. So we have got the negative, means positive to negative, the present worth. So we can take at 11%, we have got the 17.1. At X%, we don't know at what X is it. Present worth, we know that at X% is 0. And at 12%, we got minus 6,268.8. Means this value, the present worth is 0 at some X%, that we need to find out. So by using the equation, IRR is equal to, or I is equal to, see the percent 11 plus present worth of at 11%, alternative 3 at 11% minus present worth of alternative 3 at X%. Then present worth at 11%, minus present worth at 12% into difference, that is 12 minus 11. So here IRR is equal to 11 plus substitution, that is 17.1 minus 0 divided by 17.1 minus of minus 6,000 minus 6,268.8. So into 1. So now by finding this value IRR, so how much I'm going to get? IRR is equal to, it is of course it is complete this factor 17 by larger value, so it will be 11.0001%. Okay, so which is very important point here, which is less than MARR, which is less than MARR. So straight away I can cancel out this alternative. This cannot be acceptable. Why? Because this is not acceptable. Why? Because it is the less than the value of minimum attractive rate of return, which is the 12%. So minimum attractive rate of return is 12%, but it is falling below the 12%. So straight away, without any comparison, I can cancel out the alternative 3 and I can compare only these two. I can compare only these two. What is between alternative 1 and alternative 2 only I can compare. See here, if you look at the comparison between the alternative 1 and alternative 2, alternative 1 has the highest internal rate of return at which the 15.81% compared to the alternative. So the best alternative can be chosen as alternative 1. Alternative 1 will be selected. So here the comparison only between the alternative 1 and alternative 2 only. Why? Because alternative 3 is falling less than the minimum acceptable rate of return. So that will not be considered for comparison among the 3. So we'll compare between only alternative 1 and alternative 2. Okay. So with this, I stop today.